Start streaming.
Where's load?
Today's the 18th.
Today's 18th all day.
Really?
All day. Remember, it's not what you do, it's who you do it with. So partner up. Find somebody that knows what's going on, and I'll be around to help in a second.
So can we use more than one properties?
Yeah, you're going to need more than one. I use more than one. I use two in that
No,
one.
I mean, but like,
So you can use the same one twice.
No, so for like number 3, if it was 2 and 3. Like if it was 2 properties, like I can do that.
Yeah. Those are the 3 moves you're allowed to make. You make them in any order you want. Repeat moves, whatever you need.
Yo, he's just disrespecting
Wait.
David.
I'm confused.
You have 3 moves you can make. Move 1, move 2, or move 3. 3 different types of moves, right? You can do as many moves as you want. You can repeat moves. Okay? What do you need to do?
If A equals B, does that mean B equals A? B does?
Yeah, it's not, it has nothing to do with this, but yeah. Alright, we are live. So, song of the day, like I was saying, is Karn Evil 9. The full title is Karn Evil 9 First Impression Part 2. It comes from the album Brain Salad Surgery by Emerson, Lake, and Palmer, who were 3 of the members, the headliners of this band. This band was gigantic. And it's, again, from 1973. In the 70s, one of the things that was popular was fusion, which is really just this idea of combining lots of genres and putting them all together. So what they did is they combined classical music with rock and jazz. They created this song, which is, I wish, some of it, because we can't play the full thing every day, obviously we want to get different songs of the day, but I wish the beginning of it was like, as you came into class every day, just push a button and it would show up. It's a great intro. Here it is. Karn Evil 9.
Okay, this is actually kind of jazz.
Yeah, jazz rock.
Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you
Start at C, make it look like that. You can change anything to an A if you want. 2 C's in a row can turn into a B if you want. And if you want, you can take the whole dumb thing and double it. Now, my hint to you, turning that into an A doesn't really do much for you. We don't have 2 C's, so we can't do move number 2, right? So you should probably start out by doubling the whole thing. 2 C's. 6. If you need help, I'd be glad to help. Work together. Are taking this side and making it look like that side. You don't have to touch the right side.
There's nothing to do with the right side. It's all.
You want to make that look like that. You don't touch the right side. Okay? So take C and double it. Now you've got 2 C's over here. Okay, we're getting closer. That's 2 letters. We need 3. Right? We also need 2 of them to be a B and an A. So that's for you to figure out. So again, take the C and make it into that. If you need an example, look at this. I had CB and I need to make it look like that, right? So I started out with what I was given. I doubled the whole thing, and I got double CB, right? And then the last thing I did is I changed the C and the B to A's. Here are the steps that I did. Move number 3, right? Property number 3 allows me to double everything. That's what I did. Move number 1, property number 1 allows me to change things to A's. That's what I did here. Okay? Go get it. Work together. Dykema knows what's going on.
gypsy queen in a glaze of Vaseline will perform on guillotine. What a scene, what a scene. Next up on the side, William Beasley said hi to Alexander's ragtime band. Dixieland, Dixieland. Roll on, roll on, roll on. See the show.
Yeah, so for move number 2, property number 2, it has to be 2 C's right next to each other. Right? Otherwise, it goes to the Alright, that's Carnegie 9, Everson, Lake, and Palmer, ELP. Alright. So, like most of my classes, you guys seem to have an interesting way of interpreting the rules. Right? Like number 2, do the C's have to be next to each other? Valid question. I don't know why everyone asks that. But yes, they have to be next to each other. I've seen other people that are like, see how this doubles everything? They're just like, I'll just double whatever I want. But it's fine. I understand. It's new, it's different, it's weird. And actually, the 2C question kind of makes sense, right? What if we could? I just didn't write anything between. I'd probably give a more clear example if that was the case, right? But no, 2 C's in a row turns into a B. That's the idea. So let's look. Who thinks they have number 1? Dyke, how about I borrow yours, right? Sugar Dyke. Because you were rocking.
I don't know about the other two.
No, that's cool. It's cool.
I just took a wild shot in the dark for the others.
All right, so the only thing I'm going to critique right off the bat is that you need to write what kind of moves you made. Like, did you use property 1, property 2, property 3,
Oh, my
right?
bad.
So check out what he's got. So he says, I need to get from here to here, right? So what he did is he doubled everything twice. He did 2 moves in 1 here. So he doubled the C to make 2 C's, and then he doubled that to make 4 C's. So he used property number 3 twice, which says you can double stuff, right? So I would add in that to get from here to here, you have a very interesting way of laying this out. He used property number 3 twice, okay? And then to get from here to here, he used 2 different properties. I don't know why he did it all in one move, but he did. First off, he said, look, I've got 2 C's in the middle, right next to each other, so I can turn that into a B. What property is that? Property 2. So use prop 2. Again, you need to write what props you used.
All right, I don't remember
Okay?
that.
And then last, he turned that last C into an A, which is property number 1, right? You can change anything into an A. So that's prop 1. Are you feeling better about this now? A little bit? Okay. Dykeman, nice job. Way to persevere. Oh, sorry about the yawn.
What?
Didn't happen yet, but it's on its way. He's going to go to the Warriors. It's going to happen.
Oh.
All right, so that's how you turn that into that.
Okay.
We doubled it again, switched the 2 middle C's for B, switched the last C for an A. All kosher. Anybody think they got number 2? Haley. All right, so this one says we start out with CAC and we need to get to CAC, right? So here we are. I'll zoom. So she says right here, here's CAC to CAC, right? So she started out with CAC and then doubled it with property number 3. Cool? Doubled the whole thing. That's kosher. Then she switched out the middle C's for B. That's property number 2. Now she's close. She has Quebec, which I'm pretty sure is the capital of Canada, right? Parlez-vous français? Montreal? Quebec? Right? Something like that. Quebec City. So we have Quebec. And then she changes that to CAC by switching the B for an A, which is property number what? Which one allows us to switch out letters for A? Prop 1. And so she did it. Feeling decent? Are we starting to pick up what I'm putting down? A little bit or absolutely not? Wonderful. That sounds great. So let me show you in slow-mo how this is done. So number 1 said we are going from C, and we want to end up at CBA, right? So here's what we did. This is what Dykema did. Dykema first took the C that he was given, and we say that we're given that, right? And then his next move was to double that C. And the move that allows you to double it is property number 3. So he writes that. That's how he did it. You with me? Are you with me?
Yeah.
Let's go. Wake up. You're not with me. You're lost. It's okay if you're not. If you,
wake up, I said.
gotcha. Oh, gotcha. The jokes. So, yeah, exactly. But no. We double it again. And we do that by the same move. Prop number 3, right? Allows us to do that. So now we're here. Everybody cool? David, you here? Good. All right, next thing. He noticed the 2 C's in the middle can be turned into a B, so he did that. And that's property number 2 that allows him to do that. C prop 2 says, oh, whoops, you don't. Let me zoom out. Property number 2 says you can take 2 C's and turn it into a B, right? Just has to be in a row. Cool. And then the last step he did is he switched out the last C, this C right here, for an A. And now we're where we needed to be. And he did that last one by prop number 1, because prop 1 says you can switch anything for an A. Okay? So we have what he did, and we have his justification for it. Here's the rule that he did, the move that he made. Okay? We start here. We double it. That move allows us to do that. We double it again. That move allows us to do that. We switch out the middle C's for a B. Prop 2 allows us to do that. CBA, we switch out the C for an A. Prop 1 allows us to do that. Are you feeling better? I got you about 50%?
C.
6th hour. What is going on here? You guys are my most talkative class all the time. What's the deal?
We're depressed.
Yo, tank.
Why?
Brother.
Just Wednesday.
I don't understand.
Deprimido. I thought so. That's what Miss Gigi was. Yo tengo deprimido.
Yikes. So, number 2,
Second languages.
CAC, and we're trying to get to CAAAC, right? We just did this one. Haley got it right. So what she did first is she doubled the whole thing. Seems to be a popular move, and we get kakak. Kakak, kakak. All right, and that was done by what move? What allows us to double it? Property number? Prop 3. Very good. The next thing she did is she noticed, hey, middle C's together. I can switch that for a B. I'm going to do that. So then she gets kabak. Right? And that's property number 2. And then to change that into an A, that gets us home, right? We win. So she does that. She changes this into an A. And she's allowed to change anything she wants into A because property number 1 says she can. And now she's done. Swag box, because we finished it. Okay? Feeling better?
Yes.
All right. Now let's look at number 3, the toughest one. It's actually impossible. Sometimes that happens, man, right? Sometimes stuff is impossible. Shouldn't let you hold you back, you know? Like, be like Danny Mao. Everyone's telling him, like, you can't be a quarterback. You suck, right? But he's still out there throwing interceptions every day, okay? Proving him wrong.
So funny, kid. So funny.
Shout out to Danny. Follow your dreams, Danny. Follow your dreams. Don't let anybody hold you back. All right, so they say it's impossible. Let's find out. Let's see if we can prove that it is, right? So here we go. We start out here. That's given, right? Now we need to get to here. Let's look at our options. We can change something to an A. But if I do that, right, if I change either of those C's to an A, we're never going to get them back. We have no way to create C's. This doesn't create C's. This doesn't create C's. It creates B's, right? This doesn't create anything we don't already have. Yes?
I don't know if this is right or not, but before you do property 3, can you change the original thing before you do property 3?
How would I change it?
Well, like for instance, if you, I don't know, I was saying like.
Say if you do another
Yeah, if you,
step
like,
and then.
Yeah, you can do 1 or 2 first if you want.
Yeah,
Yeah.
and then change, duplicate it.
But here's the deal. If I change something to an A,
Yeah.
okay, if I change this to an A, is that going to help us in any way?
I was just saying.
Maybe it will, maybe it won't. Let's try it. So she says, let's try prop 1. Okay? Prop number 1 gets us CAA, which is what you wanted, right? Switch those out. That looks pretty good. Now what should we do next? We can't use prop 2, right? We don't have double C in a row, so that's not even an option. 1, that is not what we want to do, because once that C's gone, we can't get it back. So I guess we want to double it, right? Let's do prop 3. And look what happens. We get CAA, CAA. But that's fine, because if we can get rid of those A's, we win, right? But do we have anything that gets rid of A's? No. We don't. Do you see how A's are permanent? They're permanent. And C's are really valuable, because if we don't have C, we don't have a way to make them, right? They're a finite resource. There is no planet B. In this case, there is no planet C. All right. So we're stuck. We can't get any smaller than this. We need to get to 4 letters, so that doesn't work. So we try something else. So let's double it to begin with. We can't use prop 2, so we've tried prop 3. Let's try prop 1. We tried prop 1. Let's try prop 3 first. Prop 3 allows us to double it. So we get cacac, right? And now we've got 6 letters and we need 4, so we need to start shrinking things down. The only thing that shrinks down letters is this, right? We can switch out stuff for A, but it's still going to be the same number of letters, just different letters. This guy doubles the letters, so we need something that makes it smaller. So switch these out. We get Quebec, right? Oh, Canada. And that's prop number 2.
How did I miss that?
And you can't take out the B.
Yeah, you can.
We can make it an A, but we can't remove it. You see what I'm saying? We're always going to have 5 letters. Is there any way to get to 4 letters from here?
Yes, subtract the B.
We can't subtract it. We're not allowed to.
You said it was
There's no rule that we're allowed to. That's why this is impossible, and I've proven it. Because we've tried starting with 1, and we got stuck. There was no other possible moves, right? It wouldn't have worked. We would have had way too many letters. There's no point in going on. Same thing with this when we double it to begin with. We end up with too many letters. The smallest we can get to after we get 6 letters is to make it down to 5 again. We can't make it to 4. So this is impossible. We had 3 possible options, which allowed me to test them all and figure it out. Remember yesterday, we had infinitely many combinations of integers, right? And so we couldn't test each one. We had to use variables, which made it more complicated. This one, even though it's complex, isn't nearly as complex because we can test out stuff and prove that it's wrong pretty easily, actually. So this one's impossible. Now, why am I showing you guys this stuff? Because today, we're going to get into proofs. And here's how proofs work. You make a move, and you tell what the move is. This is the important part. We're going to start out with algebra, because in theory, you guys took the class last year and know how to do it. That's going to be this side, okay? That's going to be this side. This side is the geometry, the backing up what you're doing, okay? The y, okay? So here's what you're going to do. You're going to get out your stuff from yesterday, your proofs toolbox. You should have that.
I got it.
Get it out now. Oh, man. First one I missed all day.
It's like we bowling.
Oh, thank you, Kate. Thank you. Squeak. So here's your proofs toolbox. Mine is colorful, yours isn't. Words are hard, math is easy. Go. So, do it. So, words are hard, math is easy. You know this stuff already, you just don't know you know it yet. Okay? So let me read the words, and then I'll translate those words into math. You know the math, the words are hard, okay? So, addition, property of equality. These are the properties of equality, things that are true if we have equal statements, okay? Equal signs, equations, things you should know about. So if A equals B, well, what does that mean? It means if the left side equals the right side. It means if they give you an equation, okay? Then you are allowed to add the same number to both sides. So check it out. I had A and B, right? I have A and B here. The only difference is I added C to both sides. So give me a number for A and B. 2. So 2 equals 2. That means these are both 2s. Give me a number for C. You did give me a letter. 6. So we had 2 plus 6 on both sides. 2 plus 6 is 8. So 8 equals 8. Still true, right? Yeah. Do you see how this doesn't change anything? It's just a different way of looking at it. 2 equals 2 the same way 8 equals 8. They have the same relationship. They're the same, right? We're allowed to add to both sides. Remember we talked about this. You guys ready for this? Ladies, you ready? Okay, so we talked about this. As long as you do it to both sides, it's fine. If you do it to one side, it's child abuse, right? But if you do it to both sides, it's algebra, right? You cannot go to jail for that legally if you do it to both sides. I won't go back. I refuse.
Or just be considered double felonies.
Multiplication. They can't arrest a couple for the same crime. Multiplication, property of equality. Subtraction, property of equality. We didn't talk about that one yet. So subtraction, property of equality says, if I have an equation, I'm allowed to subtract the same number from both sides. It's still all good, right? Am I blowing anybody's mind here? No. We're allowed to subtract from both sides. It's like the only thing you learned in algebra, right? Multiplication property. We're allowed to multiply by the same number to both sides. You dig? Division property. This is the one that I always have to crumple up and start the notes over on, because up until this point we've had if, then, if, then, if, then. This one has two conditions. If both of these, then this. And I always forget about this one. And then I have to crumple up the notes because this is permanent marker. And if I mess up, then it's no good to you, right? So when I'm doing this at 2 in the morning, that happens and I get very frustrated. So,
You swear?
never. If A equals B and C is not 0, that's what that means, does not equal 0, then we're allowed to divide by C to both sides and it's still going to be the same. We're not allowed to divide by 0. We're not allowed to. It breaks math. Tomorrow I'm going to show that to you, okay? You might think, well, you divide by 0, it gets 0. No, it doesn't. I'm going to show you what happens if that was true, okay?
Is that an and symbol then? Or
That is a not equal to symbol.
not equal to?
It's a line through it, yep. It's equal sign with a line through it. Okay? So you can divide by any number you want except 0, and it'll still be fine, okay? Calculus is what happens when you say, what if we did divide by 0? Like, what if we could? And you explore that, and it's awesome. Okay, but for now, we're keeping you inside the box of algebra. That way, when we break outside that box and say, but what if we could, right? Then it means something, right? It's like making music. If you just play a bunch of random notes, it's not really music, it's noise. Because you don't have any intentionality to it. You don't know what you're doing. You're breaking all the rules, but you never knew the rules to begin with, so it doesn't mean anything, right? Rebel without a cause. But if you know the rules and if you've established them in your song and you've laid down some ground rules, and then as soon as you bust out of that, oh man, you just entered a whole new world, right? Okay? So for now, we're starting in the world of algebra. Eventually, you get to the world of calculus, where dividing by 0 means something.
So basically calculus is pointless.
No, calculus is like, what if we went beyond the rules of algebra? Because there's all this math out here. We make the rules. We are the creators. So why not? And then we do that, and we find out what that means. And there's a lot of implications, okay? It's like being like, so what if we could time travel? There's a whole lot that could go wrong with that, right?
Didn't you say that it's
a can of worms.
bad stuff that you can't time travel?
Yeah, the math implies you can. There's no reason why you shouldn't be able to. Reflexive property of equality. This one's super hard. You ready for this? If A, then A equals A.
That is my story. No one cares about your story. We're in math.
Andre, put it away and learn something.
That's her.
Who is it? Who's making the thing? All right, please put it away. So if A, then A equals A. Did I blow anybody's mind here? Good. If 2, then 2 equals 2. Fantastic. The hard part about this one isn't that it's hard. It's that you're going to confuse it for symmetric property. Reflexive, think reflect, mirror, right? Same thing on both sides. Symmetric means that it's the same thing on both sides, but not really. A equals B and B equals A.
Oh, I understand.
Right? 2 equals 1 plus 1. That means 1 plus 1 should equal 2. Again, shouldn't be blowing anybody's mind. Go ahead, Andrew. All right. Next page, transitive property of equality. This one's the fun one that everybody loves. So check it out. The pen is touching the paper. The paper is touching me. Therefore, I am touching the pen. Ah. So what does this mean? A equals B. A equals B. B equals C. We can cut out the middleman, and we know that A equals C. Cool? Let's pause for a second. 6 hour. What is the deal today?
We don't have any
energy.
Why don't you have any energy?
No, Sotra somos.
None at all. I'm bringing it. Where are you?
We're being respectful.
Get on my level. I mean that seriously.
Can't get on your level.
Both Haleys. Eyes up here. It's ridiculous.
Why'd you lean back? Because I wouldn't listen.
Usually teachers would be glad that we're quiet.
No. I want you involved. I want you here. Present. Okay?
You want a present?
No.
I'm tired.
And your jokes need to be better if you're going to make them. Okay? The bar is very low, but you keep tripping over it. All right? So, transitive property of equality. Here we go. A equals B and B equals C. If that is true, then we know that A equals C. We're cutting out the middleman here. Again, the idea is if I'm A and I'm touching the paper, that's B. B is touching the pen, that's C. Therefore, I'm touching the pen. A equals C. Okay? This is disgusting. Here we go, right? I am touching the floor. The floor is touching you, and you, therefore, are touching me. Stop it! Okay? This is disgusting. After I realized that Danny was sitting there, and Danny was my example in a third hour, I stopped touching the floor the rest of the day, because I don't want to touch that kid. Okay? Aha! So there's a great point. So even if I'm not touching the floor, I'm touching the chair, which is touching the floor, which is touching you, right? So we have an A, B, C, D thing going on here. We cut out both middlemen. That's the transitive property. That's what I'm talking about. All right. Now, substitution property equality. If there's one thing you learned in algebra, it was how to plug numbers into an equation and type it all up, right? So here's what it is. Words are hard, math is easy. Let me explain it. If A equals B, then B can be substituted for A in any expression. What does it mean to substitute? To switch out, right? Remember when you had a substitute the other day? They're basically the same thing as me, so why not just interchange them, right? You learned so much that day. So here's the idea. If x equals 5, then whenever I see x, I can replace it with 5, right? They're the same thing, so why not switch them out? 2x plus 1 I give you. If I tell you x is 5, can't you switch out x for 5? Yeah. Yes, you plug it in, right? That's the one thing you're good at. You don't know why we plug it in, but you know it works. Here's why. Substitution property of equality says you can. Okay? Those are the moves we're allowed to do today. You need to know 2 more. Flip to your postulates page, second to last page in your packet. Okay? In your proofs toolbox. Okay? You know these already, so I'm going to fly through it. Segment addition postulate, SAP, SAP for short. Okay? This thing says if we have A, B, and C collinear. What does collinear mean?
Function.
Same line, on the same line. Co means same line, linear, right? So collinear. Look, they're on the same line. And it says B is between A and C. Yeah, it is. Then we know that AB plus BC equals the whole thing. Right? This piece and that piece adds up to the whole thing. Make sense? You've been doing problems like this before. Let's just formalize it. Same thing, but not with segments, but with angles. The angle addition postulate. It says if we have 2 angles here and here, they add up to the big angle. Again, if D is in the interior means inside, right? Inside of the voices that I ignore, the internal voices, right? Most of the time.
You have inner demons too?
What? No, not now. All right, if D is in the interiors of ABC, this angle, see ABC, the angle? Then we know that ABD, this angle, plus this angle, equals the whole dumb thing. Are you seeing it? Yeah. This angle and that angle adds up to the whole angle. That's angle addition postulate. It's so easy, we don't have a proof for it because it's not a theorem. We can't prove it. We just have to accept it to be true. And if it's not, all of math falls down around it. So these are our foundation, our postulates, our leaps of faith. Angle addition, segment addition, we add up the segments, they add up to the whole segment, right? Angle addition, we add up the angles, they add up to the whole angle. Questions, comments, concerns, other than from mental health?
No, sir.
Wonderful. Those are the rules. Let's play the game. Let's play a game. Here we go. Let's look at some examples. Everybody loves examples, okay? Here we go. So,
We don't do drugs.
check it out. Here we are.
Heroin.
All right.
Sorry.
Either get funnier or shut up. It's drugs. We get it. It's funny because you're in high school. Haha. No one has ever made a joke about that before. And a teacher wouldn't dare do that. Oh my gosh, I'm so edgy. No, you're not, okay? Again, I'm not mad. You're just wasting everybody's time. Just be funnier. Like, either go there or don't, okay? So here we are. X plus 5 equals 9. I give you that. I want you to turn that into x equals 4. We know how to do this. What are we going to do? Subtract 5 from both sides. Now, the question is, okay, you know how to do that. It's from algebra. Why are we allowed to do that? What rule says we're allowed to subtract 5 from both sides?
It's just there.
The subtraction property of equality. How about that one? We're allowed to subtract the same number from both sides. Let's go, kids. So, first thing is I write down what I'm given, and I say that it's given. That's where I got it, okay? Second, I subtract 5 from both sides. We call it the subtraction property of equality. That's the reason. I need this. That's what's new. You know how to do this. That's the new thing for today. Then we go down here, and therefore x is 4, because 5 minus 5 goes away, and 9 minus 5 is 4. We're done. I don't need to tell why I got this, because it's just by arithmetic. We assume, you know what that does to us, that you know arithmetic, that 5 minus 5 is 0, and 9 minus 5 is 4. We don't need to write a reason why. Our audience isn't dumb, okay? Eventually, this will be obvious, too, and we don't have to write that, but today it's new. So what did I do? I did a swag box, 2 boxes in a row. Normally, you end your proof with a box, like when you box an answer, right? Or you write QED, which is Latin for the proof's in the pudding. I prefer the boxes, and then I do 2 boxes because I'm a big deal. Swag, right? And you can make the box into a little box.
Okay.
Moving on. Another one. 2x minus 3 equals 5. So we're going to need to add 3 to both sides. What property is that? The addition property of equality. Wow, you're so good. You memorized it already. No, you didn't memorize it. It's you understand what it means. When we add stuff, it's the addition property. We're also going to divide by 2, right? So the division property of equality. I'm going to do the adding first, right? I'm going to prove that x equals 4. So I need it to look like that for me to be done and win. Here we go. I start with the given. Then I add 3 to both sides. Addition property of equality. That makes this. Again, don't need to justify it. Just a therefore will do. Negative 3 and 3 makes 0. 5 and 3 makes 8. Are you smelling what I'm stepping in? Yeah. Wonderful. Then I divide by 2 to both sides. That's division property of equality, which says I can divide by any number I want to both sides as long as it's not 0. 2 isn't 0, so we're good. X is 4. 2x divided by 2 is x. 8 divided by 2 is 4. Swag box. We're done. Thomas, what's up?
If you wanted to, could you put the addition property where it says 2x equals 8 or no? Does it have to be where it's at?
Nah, right here, because that's where I did it. Okay? Next thing. Here we are. Before we go on, tell me what properties I'm going to use.
Division and subtraction.
I'm going to use addition to undo the subtraction. So addition property is going to come up, and then I'm going to do multiplication to get rid of division, right? It's all right. I understand what you mean. Every time you talk, I know what you mean. It's not what you say, but I know what you mean. We're going to prove that x is 45. So we need to make this look like x equals 45. So here we go. Given, add 6, addition property. That gets us here. Last step, multiply by 5 to both sides. Done. That's multiplication property. I need to see that. Then we get this. X equals 45. Swag box, we're done. Do I have you at 50% at least?
Yeah.
Wonderful. Ladies and gentlemen, now it's your turn. Here we go. I've taught you the game. I've shown you the rules. I did some examples. Now it's your turn. So here we go. Number 1, I give you this. Prove that x is 6. Another way of saying that is to say, take this and make it look like that. And write your steps and show me what moves you made. What moves are we going to make here? We're going to use subtraction property and division. Do it now. Life is not about what you do. It's who you do it with. Go.
On the what?
On a piece of paper.
Piece of paper, you dingus. Go get it. Graph paper back there.
Everything I say is backwards.
I'm like a Siamese twin. Not yet put together. Wait.
Okay. Sure.
Work together. I'll be around to help.
That's a green light.
Whoa.
Get going, get going, get going, get going.
Oh, and you're
Let's go.
going.
Wonderful. Cranky today. This hour is making me cranky.
I'm just
Mostly because you
exhausted.
guys are so much more capable than this.
So what this is solving for x with more steps?
Yep, basically it's solving for x. So what I would do is I do the algebra first, and then I go back and write why I was allowed to do that. Why was I allowed to subtract? Well, the subtraction property of equality says I can. Right? Again, we're starting basic today. It's going to seem really pedantic because it is. And then we're going to get to the geometry, and hopefully it won't be such a big jump. You'll be used to how we're supposed to make a proof, and then we'll go there. Eventually, we're not going to do this left side, right side nonsense. We're just going to write it out in words. Okay? And it's going to be fine, because I'm going to build you up through baby steps. Okay? So if you did the algebra, now write why you were allowed to do
Calm down.
it. If you subtracted, it's because you used the subtraction property.
The answer is 5. Don't talk.
I got 37.
I want a.
I got
Okay.
Eyes up here. So, first thing you should do, or at least first thing I did, there are lots of ways to do it. PEMDAS is a lie. But the way I did is I started here. I took the original problem, and I wrote it down and I wrote given. You need to write the original problem and say why you know it. It's given. Next step was subtraction property of equality. Everybody up to speed with me so far?
Yeah.
Wonderful. Next thing I did is I subtracted them and got this, right? That's what that simplifies to. 5 and negative 5 go away. 17 minus 5 is 12. We're here. What's the next property of equality I'm going to use? Division property. I'm going to divide by 2 to both sides. Bam, there it is. Write the reason. And then after that, I get x equals 6. Swag box. Don't forget the swag box.
That was a green light.
What
the
is
most
the
important
swag box?
It just means proof done. You could also write Q.E.D. which basically stands for
Wait, you
Latin
actually
version
want
of
us to
proof.
write this way?
Yeah, it's important. How do I know the proof's done? It's the most fun.
When you
Right?
box the answer.
Yeah, that's true. But not all proofs are going to be algebraic, so there won't always be an answer. Number 2. Number 2. Words are hard, math is easy. Let me read the words and then I'll give you the math. It says given. A, B, and C are collinear. What does it mean to be collinear? On the same line. Co means same. Linear means line. On the same line. They tell you that AB is x minus 5, BC is 3x plus 5, and AC is 5x minus 14. We're going to prove, and I'm going to say it a couple times because you're going to forget it. Okay? Curveball, but I'm tipping my pitch, so you better hit it. Prove that BC is 47. I'm going to say it again. Prove that BC is 47. Prove that BC is 47. It's not going to matter. No one ever remembers. So here we go. It is a plus 5 right there. So first things first, I take all those words and I make a diagram. A, B, and C are collinear. Done. You don't need any of that stuff. It's all right there. AB is collinear. Or I'm sorry, AB and C are collinear. They told us AB is x minus 5, BC is 3x plus 5, and they told us the whole dumb thing AC is 5x minus 14. That's given.
Your head is in my way when you go to talk. And then I can't.
Oh no, I will try to do better. So, first step's going to be segment addition postulate. We need to show that AB, that piece, plus BC, that piece, equals AC, the whole thing. That's the first step. Right? You've been doing this. Now we're just documenting our work. The next step is we need to make this into an algebra problem. Right now it's geometry. We got a bunch of letters here, right? So here's what I do. I substitute, right? That's substitution property. When we plug it in, what we're really doing is substituting, switching out. AB is x minus 5, so I can switch them out, right? BC is 3x plus 5, so I switch them out. AC is 5x minus 14, so I switch them out. Now it's just algebra, right? And in theory, you took the class last year. So you should know what to do now. We're going to get our x's together. Terrible idea in real life, great idea in math. You should do that. Work on that.
So I add the x's together.
Great idea. We're going to get 4 x's over here, right? Get x on its own. Do it. It's all right. We're going to get you out of this one, okay? This one's the one.
Times the char mod.
After you do that, we should get to here, right? We're just condensing. We don't need to justify that. That's by algebra, by arithmetic, really, okay? We have 4 x's on the left, the negative 5 and the plus 5 go away, right? And on the right side, we just get 5x minus 14. The way I did it is I subtracted the 4x from both sides. You might have subtracted the 5x. That's okay. You'd get a negative x over here. Negative x equals negative 14 means positive x equals positive 14. Okay? What I did is I subtracted the 4x. That's subtraction property of equality. Now, don't be confused. Just because I wrote it next to the 14 doesn't mean I'm subtracting it from the 14, right? 5x minus 4x is going to be 1x. That 14 is going to stay there. And I get this. 4x minus 4x is 0. It's okay to have 0. It's okay. What's my last step going to be? Move the 14, add it over, right? Addition property of equality. I do it to both sides. And then boom. X is 14. Swag box. Are you smelling what I'm stepping in?
Yeah, I'm kind of.
Okay. That's the idea. It's pedantic. It's silly. We're writing a lot of this stuff out that really shouldn't have to be written out. But that's the beginning of geometry, okay? I want you to get used to the format. Do a step. Tell us why you're allowed to do it. Do a step. Tell us why you're allowed to do it, okay? Again, the key here is segment addition postulate, starting it all out. I need an equation to represent a relationship between these guys. How do I know that these two add up to the whole thing? Well, segment addition postulate says it does. Okay?
That was actually pretty simple.
Good, wonderful. That's good to hear. So that was number 2. You ready for number 3? Yep. Number 3, it's back to algebra. So check it out. Let's just walk through this in our brains. We're not actually going to do it. Okay? You're not actually going to do it. What are the 2 properties I'm going to need to get this to look like that? Addition property and then multiplication. You can do it in either order. If you multiply by 2 first, that's going to give you x minus 6 equals 38. That's okay.
Which isn't bad.
It's not bad, right? It's division that gets you in trouble when you do that first, right? We'd prefer the prenup, remember Kanye, right?
Yeah.
So, number 3, here's what I did. Added 3 to both sides, addition property, we get here. Then I multiplied by 2 to both sides, multiplication property, we get here. Good? Now, what's the thing I told you to remember about number 2? Yeah, you don't remember, do you? So it turns out we found out what x was, but we never found BC, which we're supposed to prove to be 47, which means we weren't done. So what we have to do is go back and write that BC is 3x plus 5. How do we know that? Because they gave it to us. Remember that? They gave it to us. And we know that x is 14 now. Good job, but you're not done. So now I need to plug in 14, that's substitution property, and then I get BC is 47, because 3 times 14 plus 5 is 47. You're not done until you reach the thing they want you to prove. Remember all those quizzes and tests I told you to not just solve for x, but actually go back and plug it back in? Yeah, that's why. And then no one did it. And I told you this time again, and you didn't again. Every class it's been the same way. You're not alone. You're all morons, okay? Take some comfort in that. So here we are. 3 is done. On to 4. Number 4 says, words are hard, math is easy. Let me read the words to you. Given D is in the interior. Interior means inside, right? Of angle ABC. So imagine an angle with a dot on the inside. That's D. Measure of ABC is 100. ABD is this stuff, CBD is that stuff. We're going to prove, I'm going to say it twice, that the measure of angle ABD is 50. We're going to prove that the measure of angle ABD is 50. Words are hard, math is easy. Let me draw a diagram for you. Ah, colors, we like that. See how I told you that ABC was 100, so I labeled that. I remember telling you ABD was x over 2 plus 30, so I labeled that. I remember telling you that CBD was 3x minus 70, so I labeled that. Now, we're going to use the angle addition postulate to tell that, look, those two angles, the green and the red, are going to add up to the blue. You smell what I'm stepping in?
Yeah.
The two smaller ones add up to the big one. Your next step is going to be what? What property are you going to use? What do we do next?
You plug it in.
Plug stuff in. What property is that? Substitution. Remember you had the substitute, switch stuff out. Boom, we switch stuff out. ABD is that, so why not switch them? CBD is that, so switch them out. ABC is 100, so switch them out. Now we have algebra, which in theory you know how to do.
Good stuff. Bad.
Get your x's together. Here's what happens. Negative 70 and 30 makes negative 40. Okay? That's arithmetic. X over 2, 3x is 7x over 2. And you're like, wait, what? Let me tell you why. Let me tell you why, okay? If you're tripped up on these guys, that's okay. That's not the point of today. But I'm going to teach you about common denominators, okay? Common denominators. This guy's over 2, that guy's over 1, technically. They don't have common denominators, so we can't have them together. So here's what I want you to do. Think about this question. How many halves are in the number 3? Okay, stop thinking about that. No one understands it. Simpler question. How many halves are in the number 1? 2. Everybody knows that. How many halves are in the number 2 then? 4 halves. How many halves are in the number 3? 6. So that's really 6 halves, and we're adding it to 1 half. If I have 6 halves and Dykema has 1 half, how many halves do we have? 7 halves. Boom! Fractions in your head added together. Think about it. It's not hard. 6 halves is what 3 is, right? That's how many halves are in 3. There's 1 half there. I got 7 halves total. Okay? Now I'm here. I add 40 to both sides. That's the addition property. I get here. Yes, ma'am.
So it's like the same thing as 3x versus times 2 and then plus 1.
Yeah, kind of like that, yeah. So now we're here. I ran out of room. Everybody ready for the next side? What am I going to do? Make a prediction.
Can you multiply 2?
Yep, I'm going to multiply both sides by 2. That's multiplication property. I get here. And then I'm going to do what?
Divide.
Divide by 7. Everything gets divided up. Division property of equality. I get x is 40. Now we're not done because we didn't actually show that ABD is 50. So what I do is I take that 40 and I plug it in. So I'm going to plug it into what I'm given. ABD, they told us, was this at the beginning. I plug it in. What property is the plug-in property? Substitution, not subtraction, but substitution. S-U-B-S, not S-U-B-T. We plug it in. 40 divided by 2 plus 30 is 50. Swag box. Here's your homework.
That's awesome. What? No.
Oh, you need it. Wake up. You are not allowed to be this tired in here again. Ladies and gentlemen, I was smart last night. I thought to myself, I can stay after game club after 5 o'clock where I'm exhausted. I had 2 hours sleep the night before. And I can stay until like 9 or maybe midnight or maybe 2 a.m.
2 hours of sleep.
Right? Don't interrupt my story. I can keep going from 5 until like maybe midnight to 2 a.m., right? And I can work hard and get this stuff done. But I'll only be working at 25% capacity because I'm so freaking tired, right? So what I did is I went home and I took a nap for 4 hours. I came back here at 10. And then I stayed here from 10 until school this morning and got tons of stuff done because I was at full capacity working for that.
Oh, right. Oh, man.
Just kidding. I didn't do that, but I thought about it. That was my goal. Instead, I woke up at 10 and got this math problem that I had to explore. It had to do with the thing we were doing the other day. To be able to prove that whenever the numbers are odd, right, it's always divisible. You talked about that? You thought about that thing? Yeah, I spent 3 hours on that. I didn't get it proven, but I'm one step away from doing it. It was a lot of fun. And then I came back and did this stuff, right?
Come on, boy.
See you later.